All right. Hello, everyone. I'm Daniel Pierce, a developer at Indiana University, and currently a co-tech lead with my coworker Randall Floyd. So this is a talk that I titled "Defending the Realm Against the Swarm." Give a shout out for the inspiration of that title to the band Castle Rat. If you're into metal at all, you might have heard of them, or you might like them. So this is our digital collections site at IU. This is just a local instance running here on my computer. But as I'm sure everyone has been experiencing lately, we've been getting hit by a lot of bots and crawlers and spiders of various sources, some of them search engines, some of them AI scraping, what have you. And in our case, we would frequently end up with our status notifier telling us that our site was broken in some fashion, not returning, giving a 500 for whatever reason. Uh, when one of these crawlers would come by, and then frequently this would start happening, mid Friday afternoon and continue through the weekend with our whole team getting emails about how the site was down, even though it wasn't really, it was just very slow. So something had to be done. And IU has a library catalog that's just a blacklight site. And they've suggested Rack Attack. They've been running it and it seemed to help them. So Rack Attack is this rack middleware that lets you define various safe lists or block lists or throttle based upon really a lot of different things. The basic usage would be IP addresses, but it allows for more advanced usage as well. Um, so I went about integrating this, and for our site, I ended up making it more dynamic for reasons that come down to our public site runs is not run by the library development team directly, and so we don't have very good access to changing its configuration kind of on the fly or good access to the logs, that kind of thing. So I co-opted the content block system that we use for like the about page or the help page and made it store a configuration file for Rack Attack. There's a few different sections here. So you can find safe paths based on the URL that don't get any sort of blocking or throttling applied. You can apply safe IPs. This is just a list of all of IU's internal network. So if you're on IU's VPN or on campus, then you don't have to worry about getting throttled. You can block by IP range. Or by user agent, and you can also throttle by IP or by user agent. So down here, the user agents are defined by regular expressions. In this case, if your sent user agent includes the words bot, crawler, spider, meta, or if you don't send any user agent at all, then you get thrown into a throttle bucket. And then for testing here in a second, I've also included a separate bucket for Firefox. And then there's some other configuration that isn't done dynamically, but through just a config file and would require a server restart. Specifically, how many requests within a certain time limit that throttling would be applied. And then also, this is a time to live for the configuration. So if we were to change something here, the site would reload that config within 5 seconds, which is very low. That's just for demo purposes. So yeah, over here, here's our site again. You can load up a few pages, go through some things, reload the page, and within a few loads here, then the server will send back a 429 response and say retry later. As we recall, this is set up for 30 seconds. So if we wait a little bit and reload, then this will work again. But the Rack Attack dashboard still loads since it's part of the safe paths right here. Yeah, so this is all implemented in our production site. And the story of doing that was somewhat interesting because as soon as we deployed the initial version of Rack Attack, the site started having like going down again. We were getting Axios status errors. And so there was, of course, a concern that adding in Rack Attack introduced a significant performance penalty, even though I was reasonably sure that wasn't the case. But it turned out that, of course, some bot started crawling us within the hour after deploying this to production. And naturally, that bot wasn't sending a user agent at all, as far as I understand. And initially, we were not able to filter based on just the lack of a user agent entirely. That had to come as a later enhancement. So yeah, the first weekend with this Rack Attack throttling system in place was kind of rough, which was concerning and disappointing. But after that laid off a bit and we did some enhancements, then I think it's working better. We've also in production, we had a very high throttle limit. It was like 50 requests over 2 minutes, I think. So we've reduced that significantly. But the other thing that we discovered was that we had very slow responses on our catalog controller, to where it was taking more than 2 seconds to render a single time. And so basically the site was getting overwhelmed very quickly, unreasonably quickly. And the source of that slowness ended up being the very early implementation of flexible metadata that we have on this site. This was actually the initial deployment for the ounce and flex gem or flexible metadata. And so it's been around a while, and our profile that we used for flexible metadata had grown over time, and eventually exposed some performance pain points. Specifically, the catalog controller was resetting all of the blacklight settings as far as like what facets and what to show and all that stuff based upon the flexible metadata on every single request, even though that didn't change all that frequently, only if you uploaded a new flexible metadata profile. So that prompted some additional fixes unrelated to Rack Attack, but perhaps if we'd looked there first, it may not have been quite as necessary to go about implementing Rack Attack right away. Yeah, so the quick look at the code that does all this. So this is kind of the Rack Attack's initializer. It sets up the block list and safe lists and the throttling stuff. This looks very similar to what you'd see in the Rack Attack README. In our case, we're calling out to a separate class these methods here: safe request, block request, throttle request, that live over here. And this is what loads up this YAML file. It loads up each section and creates either IP address objects if it's an IP address, or regular expressions if it's a regular expression. And it saves those in memory until the config needs to be reloaded. And then the editor part of it is really just a copy of the existing content block editors, but pointing at the content block object coming out of the config. This is all up on GitHub if anyone's interested in looking closer. And I should also mention that if anyone's not aware, then the Code for Lib Slack has a bots channel that's been very useful and had a lot of traffic lately. And they also have a wiki page about blocking bots that if just doing Rack Attack isn't enough for your site, then there's stronger measures that can be applied, especially this Cloudflare turnstile that Jonathan Roshkin has made. We've not tried that yet, but if we end up having further trouble, then I think we will probably be looking into that. Um, and yeah, there's also this something that uses traffic. That's another way we'd thought about going, uh, but it seemed like it was maybe a lot to do right away. If it might have been too much work for what the payoff would be. So we decided to try the rack attack approach first just to see how things go. I think I'm done.